Right. Hey everybody, welcome to another IAEI News Live, and this is a recorded session. So I am traveling out and about. I'm not sure if I'm going to be able to go live. So rather than risk it and not provide content, I want to make sure that we don't miss an IAEI News Live, because regardless of where I'm at in this globe, the show must go on. So I am doing this. I am in Chile, Santiago, Chile, this week, and I am running on empty right now, and that would be a name for a very good song, I think. But in any case, I wanted to take some time and continue the discussion that we had. Remember, we began last week the introduction to data centers. I did manage to line up a few speakers on this topic. We're going to bring them on live at a future event. They're excited. I know Jay Prigmore is very excited. He works for Google, and he wants to talk about data centers, and he'll give us an insight. He gave me some really good guidance on some key things to consider when it comes to a data center. That I think it will be a great place to explore some examples and understand data centers through the eyes of somebody who eats, sleeps, and drinks it on a daily basis. That I could never bring that to the table. So we're going to be reaching out to more and more people, and I think in the process we're going to learn more about the codes and standards in general. Because a data center is a data center. It's a structure with a lot of computers and energy storage and whatnot inside. It's a commercial building. It has to have lighting. It has to have egress. It has to have all the different things that we talked about. So, in any case, this session, what I'm thinking is we explore Busway. I want to explore Article 368, and I want to get an introduction into Nfpa 855, which focuses on energy storage systems. Now, I'm going down the Busway route just because I believe it came up as a topic that was identified during our last session. I believe it was our last session, last week. I'm trying to think. I did go live last week. I was at the electrical safety workshop, and I believe I made it upstairs to go live. Man, I cannot remember. I'm almost positive I did. So if you recall, during that, we identified a few areas. One was heat. Busway played an important role. And then energy storage, obviously, for obvious reasons. And then I believe... I can't remember who it was, raised the whole topic of DC distribution. So that's another point of discussion for us, is DC distribution. Now, let's focus in on Article 368. And what I want to do is focus on, first I just want to focus on the overall structure of the article. So let me see if this will work. Me and iPad. Whoops. Yep, there we go. So Article 368. You have a Part 1, which is general requirements. You have Part 2, which is installation. Part 3 is construction. Part 4 is requirements for over 1,000 volts nominal. And I think that's it. Yep. So relatively focused, short article. The general requirements only has the scope. So let's take a look at what the scope says. The scope says that the article covers service entrance, feeder, and branch circuit busways and associated fittings. Now keep in mind, this is not just data centers. We're talking busway. We're talking busway, and we'll go over to the IT article here. In fact, I wish I had. This is when I wish that I had my my little buttons. But remember, the Article 368 is generic. It's it is an article that covers busway regardless of where you're applying it. So I want to go to information technology, which I think is in Chapter 6 as special equipment. I can't remember. Yes, 645 is information technology equipment. Now, we don't have a special occupancy called data centers. And I think we talked about it last week that I think somebody could make an argument for an article for data centers, because I'm sure there are special applications and special needs for that type of an occupancy type. But in any case, we have 645, which is information technology equipment, which you'll find in a data center, but you could find information technology equipment in a lot of places. And it says, oh, look at this, man, I wish I had my buttons. It says this article covers equipment, power supply wiring, equipment interconnecting wiring, and grounding of informational technology equipment and systems in an information technology equipment room. Ooh. That's interesting because 645, what's an information technology equipment room? I guess it's a room that has information technology. So let's do this. I'm going to take that. I'm going to hit copy. I'm going to come over here and pull up another NFPA link. I'm going to go into NFPA 70, 2023. I'm going to go to search. Oh, no, I'm not. I'm first going to go into general, and I'm going to click on Article 100 so that I only get the contents of Article 100. I am going to, once this populates, which there's a lot of defined terms, so let's drink a water while this is populating. So I'm drinking, I'm in the hotel, and por venir. Again, everything is in Espanol, but all right. So Article 100, I'm going to search, and I'm going to paste, and I'm going to search for information technology room, and it is a defined term, so that's good to know. And it says a room, and it's out of NFPA 75, which tells me, I hate when it does that. Where is information? I wasn't touching it. You saw that. Equipment, there it is. So because it comes out of NFPA 75, that tells me that if you are working on if you're working on an information technology equipment room, which is a room within the information technology equipment area that contains the information technology equipment. Oh, wow. I'm sorry, I didn't mean to laugh, but that was funny. Anyway, it's out of NFPA 75, so if you are working on equipment that meets this definition, then you need to understand what's in NFPA 75. So if I come back to 645, so it says the article covers equipment, power supply, wiring, equipment interconnecting, wiring, and grounding of information technology equipment and systems in an information technology equipment room. So if the IT equipment is not in an information technology equipment room, then this article would not apply. So maybe, just maybe, this could be our data center article. If I was working on a data center, would you come here to 645? Would you know to come here to 645? Would you be looking for an article in chapter 7, or no, chapter 5. Chapter 5. Special occupancies. Would you be looking for an article in special occupancies? Looking for a data center? Or would you automatically know that, hey, I need to go to 645 information technology equipment? You may be the smart ones out there that knows to go to 645. I, on the other hand, am not that sharp. So in any case, I think that if I had a data center, I would be living in 645. Now, when you look at 645.3, when it talks about other articles, it points us to Article 300, 770, and 800 for fire-resistant room boundaries when you penetrate them. If you're looking at wiring methods, you're in Article 300. Class 2 and 3 and power-limited tray cable in 722. Fire alarm systems in 760. Optical fiber cables in 770. Communication circuits in Article 800. And then CATV and radio in 800. So it gives you the pointers to those other articles and sections specifically. And then you've got your bonding and grounding. And I'm interested, it says non-current carrying conductive members of optical fiber cables. So this is optical fiber cables. And it points you to 770, but I would argue Article 250 would apply to everything else. So just because that says bonding and grounding doesn't mean you can circumvent Article 250, because this language only pertains to optical fiber cables that are in a IT equipment room. You got your classifications, you have your fire alarm, cable routing, antenna, optical fiber cables. So there's a lot in, this would be 645. Interesting. So 645 doesn't have like a part 1, 2, or 3 or anything like that. It's relatively short, but I don't see anything in here around Busway, which is interesting. So let's go back over to Busway. Busway. I can't remember what article Busway was in. Oh, I'm in Nfpa 855. That's why. I didn't want to be in 855. Let's go back over to Nfpa link. Come back over to 70. So we already talked about information technology in 645. I'm just looking to see if there's anything else in Chapter 6. It wouldn't be office furnitures. You wouldn't have industrial. All right, so I think we're okay there. So let's go back to Busway in chapter 4. Where is Busway? Where's Busway? Is it chapter 3? There we go, 368. Man, oh day. Lack of sleep really gets you going. All right, so 368 Busway. We already said that it covers service entrance feeders and branch circuit busways and associated fittings. It doesn't matter if it's in a data center or not. It tells you that you can install it anywhere in accordance with 368.10a, and A is exposed, open where visible, except as permitted in C, behind access panels, and you can go through walls and floors. So unbroken lengths of busway shall be permitted to be extended through a drywall. With that, through drywalls. Floor penetrations, etc. So what we're basically trying to tell you is you want to make sure that when you're using busway, the connection points, the splicing, extending lengths of busway in a series motion, you don't want any of those terminations in an area where you don't have access. So if you're going through a wall, don't splice it right there in between the two rooms. So make sure that you're extending in an unbroken length of the busway through that wall. All right? So that's your through walls and floors. Now it tells you that you can't use busway where you're subject to physical damage. That would make sense. And you can get around that by, providing the physical damage. The other area that you're not allowed to use it is when you have in a corrosive area where you may have corrosive vapors. In a data center, I can't imagine where I would have a corrosive environment in a data center, because if it's corrosive for the busway, you know what it's going to do to a computer. Okay, you can't put busways in hoistways. So, and for obvious reasons, you don't want to damage that. I think you could probably make an argument that you are subjecting to physical damage, but in any case, you're not going to put it in a hoistway. You're not now. If you have busway that's in a hazardous location, then you can use it there, but it has to be listed for the application, or identified or specifically approved. The way the language says, it says busways shall not be installed in any hazardous classified location unless specifically approved for such use. So one way of approval is listing, but that's not the only way. If you put it in a wet location, and I honestly, I'm not even sure why. When I look at D in this list, it says busways shall not be installed outdoors or in wet or damp locations unless identified for such use. Well, I could say that about any location that you're going to install equipment. It just, if you're using it in accordance with its listing, Mark. So I'm okay with it there, the language there, because it's not technically inaccurate. It's a shame that we need it. Working platform. So none of this pertains to a data center. I mean, it's not going to be a wet location. You're in a data center, for goodness sakes. You're in a clean environment. It better be a clean environment, a well-conditioned environment. You have to have your busway protected against overcurrents, and that would be a short circuit and an overload. So you're going to have either a fuse or a circuit breaker in series with that busway. And then any taps that you have coming off of that busway down to the PDU racks or whatever it is that you're using, that's going to have a conductor associated with it, and that has to be protected at its ampacity. So all conductors. It's an Article 240 thing. All conductors are going to have to be protected at its ampacity, and we determine the ampacity based on Chapter 3. And anytime you reduce the ampacity, so if you go from one piece of busway to another piece of busway, and if the other piece of busway is at a lesser value of a lesser current rating, then yeah, you're going to have to provide overcurrent protection for that what do you call it? I was going to say transmission, but no, that transformation from one current to another, you're going to have to protect that second run of busway at its ampacity. All right. We already said that if you're going to tap off of that busway, it needs to be protected at its source. Now, another thing you're going to have to think about is the selective coordination, which I believe is in 640. We're in 645. I mean, that's in 3. Yeah, I believe it's in 645. We'll take a look at that again. In fact, let me do that now. Go out and go back over to... I'm going to open up another instance, yet another. This is the value of Nfpa link. I can open up multiple instances and point to just the article that or the area that I want. So like right now I have Chapter 1, Article 100 open, so I can search terms. I have Chapter 3, Busway article opened, and then I have Chapter 6, the Information Technology. So we're going to be looking in 645. And I believe since I'm in that article, I can search and put selective, selective, and return. And there is 645.27. And because we were on the discussion in Busway of protecting Busway, 645.27 says critical operation data systems overcurrent protective devices shall be selectively coordinated with all supply-side overcurrent protective devices. Selective coordination shall be selected by a licensed professional engineer or other qualified persons engaged primarily in the design, installation, or maintenance of electrical systems. The selection shall be documented and made available. So, let me do this. We'll do a quick search for what is a critical operation data system. I'm going to go Article 100, and I'm going to click on search. And why isn't it searching? Searching. That sounds like another terrific song. Let me refresh. All right, I am in Article 100. I'm refreshing. It's so most refreshing. And I'm going to click search. And I'm not getting the search tool. Why am I not getting the search tool? So I'm at the source. Search. And I'm not sure why I am. Let me, I'm going to put up here and find, paste, and search. All right, so I am not finding, I have 0 instances of critical operations data systems. Let me take the S off. All right, so here we go. Critical operation data system. Critical operation data system, and I can't, there it is. There it is. All right, you ready? Let's take a look. Let me show you something. So critical operations data system. An information technology equipment system that requires continuous operation for reasons of public safety, emergency management, national security, or business continuity. So business continuity would fall under that, like your Googles, your Microsofts, anything that needs to be up for business purposes. That's pretty vague. So that's what a critical operation data system is. So the selective coordination is required for these. Now that would be a business operations. Overcurrent protected devices shall be selectively coordinated. And we know what the defined term of selectively coordinated is if we go back to chapter 1 and we run down here to selective coordination, or coordination selective. I think it's a C. COO. Coordination selective. That tells us that's the localization. Oh, man. I hate when it does that. Localization of an overcurrent condition, and we know overcurrent conditions are overloads, ground faults, etc., to restrict outages to the circuit or equipment affected, accomplished by the selection and installation of overcurrent protective devices and their ratings or settings for the full range of available fault overcurrents, from overload to the available fault current. And available fault current is another defined term, which is the maximum amount of a fault current, and for the full range of overcurrent protective device opening times associated with those overcurrents. So there it is. I couldn't find it. So the challenge here is when you're dealing with Busway. Busway is a highly efficient fault delivering system. That's what it is. It delivers fault current like there's no tomorrow because it's a very low impedance. So that's our challenge with these types of systems, and when you need to selectively coordinate them. Remember, the overcurrent protective devices, if I go from, say I have a 400 amp bus run and I go to a 200 amp bus run, unless you're using fuses, current limiting fuses, specific current limiting fuses that give you a 2-to-1 ratio, you're not going to get circuit breakers to provide that selective coordination at the fault currents, unless you have fault currents that are way in the dirt, which, if you're using Busway, they're not going to be way in the dirt. Capiche? So the challenge that we have is you're going to probably have high fault currents in these applications. And to achieve that selective coordination, you're going to have to really understand how to achieve. You're going to have to understand power systems engineering to achieve the requirements of that section of the code. That's just where my opinion is. Now, a lot of these data centers use fuses, and you maintain a 2-to-1 ratio. Go home, leave me alone. I don't need to even know what the fault currents are. Up to the interrupting rating of the fuse, which is probably 200 or 300,000 amps. I know that if I have a 200 amp fuse downstream, get the right fuse catalog number. Now, don't mistake what I'm saying here. You've got to use the right fuses. But if I have a 200 amp fuse downstream of a 400 amp fuse, I've got a 2-to-1 ratio. I can hit that puppy with 200,000 amps, and I know the downstream is going to open and the upstream is not going to open. And it's just the laws of physics, okay? So I'll have continuity of service, and I'll meet the code requirement. And if you specify the fuse, then there's a lot of reasons. Now you'll get, can we probably implement a similar design with circuit breakers? Sure. You will have to possibly change the design a bit, but you can get it done. I'm not going to say it's impossible. You can do it both ways. It's definitely easier one way over the other. But in any case, Busway tells us that anytime we reduce the ampacity size of the busway, we need to protect it at its source. Now, there is an exception. It says for industrial establishments only. Now, what's an industrial establishment? Can you say a data center is an industrial establishment? My gut tells me you probably could make the argument and win the argument because you probably have qualified people 24/7, 365. Probably more so than any other industrial establishment. For industrial establishments only, omission of overcurrent protection shall be permitted at points where busways are reduced in ampacity, provided that the length of the busway having the smaller ampacity does not exceed 50 feet and has an ampacity at least equal to 1/3 the rating or setting of the overcurrent device next back on the line, and provided that such busway is free from contact with combustible material. So you've got some leeway there. All right? And that's probably, I bet you if you went back to Article 240 to the TAP rules, you'd find, you'll understand the language there. So that's an important one, and I would say, as we get down through, anytime you're protecting this busway, the biggest concern I would have is the high fault current values you're probably going to be experiencing and the challenge in selective coordination. And don't forget, you have to selectively coordinate most, if not all, of these applications, just because of what the defined term says. And it says business continuity is in there. Okay? A busway used as a branch circuit shall be protected against overcurrents in accordance with 210.20. We already know that. They talk about support for busways. Every 5 feet, you have to support it, unless you have information from the manufacturer or somebody that says it doesn't have to. So it says unless otherwise designed and marked. 368 branches from busway. Branches from busways shall be permitted to be made in accordance with. So, branches from busways. So I would say you're tapping into a feeder, so to speak. And they limit the wiring methods that you're permitted to use. They have a total of 16 wiring methods. And I'm telling you honestly, if you can't find, if your method isn't in one of those 16, I can't help you. I mean, it should be a no-brainer. I was going to say it should be no bueno, but that's no bueno is no good. It should be a no-brainer. So, and I would say that this is where you're going to see that the conductors come down off of the busway and feed the PDUs. I think I'm using the right terms. Use the chat. Correct me if I'm wrong. Do you see busway being used in applications in data centers? Is it all AC busway? What voltage level busway do you see? And then are you seeing any DC busway? I'd love to hear some feedback in that area. But you've got your IMC, your RMC, your FMC, your LFMC, your PVC, EMT, ENT, and you could use busway too. Strut, etc., channels. So there's a lot of options for tapping into that busway and feeding equipment that is probably down below. Everything that I've seen, the busway has always been up above, and then they tap off and come down. You have cord and cable assemblies. It tells you that you have to have extra hard usage or hard usage and listed bus drop cables, etc. So there's guidance and specific methods that you need to think about for cord and cable assemblies. They have trolley type busway. You have to have suitable cord and cable assemblies identified for extra hard use, etc. Remember, busway is designed. The way busway is designed, it's designed to be flexible. You're going to be moving things here and there and all that jazz. So it's very important to understand the reason someone is probably using busway is because they anticipate reconfiguration in the future. And anytime we are reconfiguring, moving things around, we have to make sure that it's durable and we do it the correct way. And then you have your, how it ends. It's got to end in a cap, so to speak. And then you have your grounding. And remember, bonding, everything is still critically important. We're not talking about system bonding. We're talking about the bonding jumpers, etc. So, and then we have some marking. You have to have the voltage, you have to have the current rating, and the manufacturer's name. All has to be visible after the installation, so you know what you're dealing with. And that's in construction. There's only one section in construction. So in construction, they can't get in to tell you how it needs to be made because, let's see, there's no listing requirement, is there? No. There are no listing requirements that I can see. Find. L-I-S-T. In fact, it says suitable cord and cable assemblies identified for extra hard usage or hard usage and listed bus drop cable shall be permitted. It doesn't say it shall be required. In 2 different locations, those are the only 2 different locations that the word listed even appears. So busway is not required to be listed. So what I was going to say was, the reason that Part 3 construction is only saying how the busway needs to be marked is because it's already required to be listed, and the requirements on construction of the busway is a part of the UL standard, but there's no requirement in 368 that all busways shall be listed. Now, if there is another area in the National Electrical Code that says only listed busway can be used, we can fall back on that. But my thought process is that Part 3 construction, especially because it's not required to be listed, probably should be expanded a little bit more to give some guidance. But I would say only if you're seeing busway that's not listed that is highly questionable out in the field. And then Part 4 is your requirements over 1,000 volts nominal, and you talk about adjacent and supporting structures, barriers and seals, drain facilities, ventilation, termination, switches, wiring, expansion fittings, neutral conductor, grounding, and marking. There's a lot more marking requirements in 368.320 than there is up above in 368.120. But that sort of gives you the layout of Article 368, which would apply regardless of where you're installing busway, and it just so happens. Now, let's go back. I'm going to go back, and I'm going to open up yet another instance of NFPA link because I want to search, and I'm going to open up NFPA 70, and I am going to do a search. Boy, why? There it is. I'm going to search for busway, B-U-S-W-A-Y. And now this looks at all. So you got 3, oops, dadgummit. Let's go back. Let's go back here, go back to search. Busway, you've got it in Article 240. You've got it in 480, that's for DC. 604, 368, 410 for luminaires. You have the definition of busway, 368. So there's no, what I'm looking for is other areas in the National Electrical Code where you might have busway be required to be listed, and I'm not seeing it. So Let's look in 240.21. 240.21. Nope. I'm not seeing anything in there where it says it has to be listed. So that's your 368. Now, if I go back to Chapter 6, if I search Chapter 6 for Busway, Busway, that's used in a 645, Article 645, Informational Technology Equipment, there is no specific requirements that says that it shall be listed or that it has to be identified for the use. So I wonder, data center Busway. I'm just going to do a search to see. Steel Trek Busway offers blah, blah, blah. There's Cisco. Ooh, stop. Stop. What is data center busway from Sunbird? I never heard of Sunbird. A data center busway is a self-contained overhead power distribution system that delivers power to a data center server racks. Well, duh, it's Busway. Busways have no cables, so these people brand labeled theirs for data center. But it's still Busway. There's no special listing requirements. Ooh. So we said last week that the UL standard for Busway is 857. So let me go on my Pooter, and I'm going to look at UL 857, organizations, underwriters laboratories, UL 857. Let me look. I have 857, and I'm going to open it, and I'm going to search. I am going to do a Control F, and I'm going to type in information. I'm going to type in technology for information technology. There's nothing there for technology. I'm going to input data center. Nothing in there for data center. I'm going to type in information. Well, I have to spell information correctly. Information. Information. Well, that's going to hit 13. I'm only 13. So information to be given, approximate information, such information to be given regarding the assembly mounting of hanging information, service equipment information, miscellaneous information, information sheets, information concerning the short circuit withstand strength. So there's nothing in 857 that specifically calls out Busway that has special requirements for use in a data center. Busway is Busway is Busway. Now you probably will get a manufacturer or two that may say, hey, I've got Busway that's specifically designed for data centers, and it could be the way they handle the selective coordination requirements. That might be part of the picture. It could be the ampere ratings of plugs, etc. But there's nothing. That would be all on the manufacturer themselves, not based upon a standard. Let's take a look at what Schneider says. Schneider says, let's do this. Let's just bring them in. I'm going to bring in Schneider. Oh, wait, no. I can't. I'm on my computer. Sorry. I thought I was searching on my iPad, but I'm not. Power secure optimization for IT, data center infrastructure, product data center solutions. So let's take a look at that. Flexible, fast, simple, I'm not seeing anything. Let me look for Busway. They've got a picture, EcoStructure pod, whatever that is. I'm going to do a search, Control F for Busway. There's nothing specifically called out on their data center. Let's look at Cisco, what Cisco says about Busway, if they have anything on Busway. What's funny is I think it's just keying off a data center and excluding Busway. So the importance of Busway, this is Legrand. The importance of Busway in modern data centers, reducing installation and maintenance costs. Yeah, so they're comparing all the wiring, all that jazz. Yeah, this looks like more of a European style. This is definitely not product that you would see here. But in any case, that's what it's all speaking to is, efficiencies and flexibility and things like that. So when it comes to Busway, we're not talking something that's UL listed for the application. All right, so hopefully that gives you a little overview of Busway, a little bit more insight. Now I want to quickly, before we end, I want to quickly take a look at, and now this is definitely on my iPad, I want to take a look at 855. This is your standard for installation of stationary energy storage systems. You're going to, if there's any application where you're going to see energy storage systems, I would think it's going to be a data center. So this is some place that I think is critical for us to review and understand NFPA 855. And what we'll do is we'll just walk down through the chapters to understand how the document itself is laid out. So you have your administrative rules. Now remember, right off the bat, I see definitions in Chapter 3. That means it's not following the NEC style manual. So be mindful of that. You have your administration in Chapter 1. You've got your reference publications. You've got your defined terms. And honestly, I think we should change. In my opinion, Chapter 3 is not definitions. Yeah, there are definitions there, but more importantly, it's the terms that are being defined. It's the terms. It's not definitions. Definition is a definition of a term. So, if anything, Chapter 3 should say defined terms, period. Not definitions. Defined terms. Chapter 4, your general requirements. You've got construction, emergency planning, hazard mitigation analysis, combustible storage, etc., etc., etc. Chapter 5 is your system interconnections, your disconnecting non-electrical systems, support systems. Chapter 6 is commissioning. Chapter 7 is your operation and maintenance. And honestly, I think Chapter 7, NFPA 70B, baby. That's where that should be. We shouldn't have that in here. It should be in NFPA 70B. So I'll look forward to your public input to take Chapter 7 and stick it over in NFPA 70B with all of the details. Chapter 8 is decommissioning. Boy, you rarely see this. Wow. A decommissioning plan, process, and a report. I mean, we could use this for everything. Wow. Chapter 9 is your electrochemical energy storage system. You have your equipment, location, installation, protection, etc., etc., etc. Chapter 10 is reserved. Chapter 11 is your fuel cell energy storage systems. Remember, a fuel cell is a little different. A fuel cell. I thought a fuel cell powered vehicle use. And then you have your superconducting magnet. You have your flywheel, lithium metal or lithium ion battery, 1 and 2 family dwellings and townhouses. Look at that. locations, energy ratings, fire detection. Ooh, I love it. Now, I wonder how much in here should be in the National Electrical Code. And then you have your explanatory material. This is how when it's not an NEC style manual, this is where they have all the explanatory materials on Annex A. Then you have Annex B, which is your battery energy storage system hazards, your firefighting considerations, etc. So that's sort of how the document is laid out. And I think when it comes to data centers, you can't get through talking about data centers without understanding NFPA 855. Now, we did recognize that NFPA 75 is another critical document, so I would think that our efforts together should explore 75 as well. So I'd love to hear your dialogue on this. Please don't forget to chat it up a bit. Keep engaged, and you can even comment on this video later. Where do you want to take this discussion and all that jazz? So that's what I've got for this session on data centers. Still, we're framing our understanding of data centers. We're getting some glimpses into other NFPA documents and some specific articles, bouncing around a little bit in the NEC, but that's okay. That's why the NEC is the way it is. All right, so I'm going to, again, stay tuned. At a future session, we're going to have some experts in to help us dig down a little deeper. Jay Prigmore is going to be one of those. In any case, ouch, I think I probably just woke up my neighbor. In any case, I'm going to call it a day or a night here in Santiago, Chile, where we're spreading the news of electrical safety globally. So don't forget, those little electrons don't realize that they're in a Spanish-speaking world or they're in a different part of the world. They act the same. Physics doesn't change, buddy. All right? Thanks for what you do for the electrical safety. Thanks for what you do for the electrical industry to remember to stay safe. And please stay healthy. Until next time, take care. God bless. We'll talk soon.